Hello everyone. Today we're going to be going over a practice quiz. So this is a practice quiz for calculus for business and social sciences. And this will be on elasticity of demand. So here we have some important formulas. As you can see, E of P equals negative P F prime of P over F of P. The demand is elastic if E of P is greater than 1, unitary if E of P is equal to 1, and inelastic if E of P is less than 1. So let's go ahead and start doing these questions. So 1, the demand equation for Roland portable hair dryer is given by x equals 1/5 225 minus p squared, where x measured in units of 100 is the quantity demanded per week and p is the unit price in dollars. A is the demand elastic or inelastic when p equals 8 and p equals 10. B, when is the demand unitary? C, if the unit price is lowered slightly from $10, will the revenue increase or decrease? D, if the unit price is increased slightly from $8, will the revenue increase or decrease? So first, I'll write down the formula. So here we have x equals 1/5 225 minus p squared. So to find the elasticity of demand, this is f of p. So this is the function f of p. We can put that here, f of p. And to find E of P, we can use the formula. We have negative P F prime of P over F of P. So we need to take the derivative of the top here of this function. We have a negative P 1/5. Derivative would be a negative 2P. And then we copy f of p over. We have 1/5 225 minus p squared. Next step is to simplify it. So here we can see we have -1 times -1. We also have a 2p squared. And the 1/5 will cancel. So letter A, is the demand elastic or inelastic when p equals 8 and when p equals 10? So first is to get E of 8. So we have 2 times 8 squared over 225 minus 8 squared. So that will be 225 minus 64. So that will be a 161. And then on the top, here we got 64 times 2. So that will be 128. Then you can use your calculator. So here we have 128 over 161. So you can see that this number is less than 1. So that means that it's inelastic. Now we do the same for E of 10. So we got E of 10 equals, we have 2 times 10 squared over 225 minus 10 squared. Directly use the calculator. We get 1.6 greater than 1. So that is considered elastic. So part B, when is the demand unitary? So we need to take E of P, which was 2P squared over 225 minus P squared, and we're going to set it equal to 1 for unitary. So if we solve it, we got 2P squared equals 225 minus P squared. 3P squared equals 225. P squared equals 225 over 3. So that is 75. Simplifying, we got P equals plus or minus rad 75. Now, this is a price, so that means we just take the positive root for prices, P. So if you get rad 75, that's 8.66. That's the price. Letter C is if the unit price is lowered slightly from $10. Will the revenue increase or decrease? So basically you have P equals 10. And then if you lower it, so if you lower it, what will happen to the revenue? So a good idea is to look at the graph. Same thing if you have P equals $8 and you increase it slightly, what will happen to the revenue? So you need to look at the graph. It has a curve like this. And on the left side, it's when E of P is less than 1. So that's inelastic. And then on the right side, E of P is greater than 1. That's where it's elastic. Now, for P equals 10, that is on the elastic side. So if you decrease the price, so that means going to the left. If you decrease the price, that means the revenue will increase. Now for P equals 8, we found earlier it was inelastic. It's on this side. And if you increase the price, then the revenue will increase. Now, in question 2, we also have a question on elasticity of demand. The management of Titan Tire Company has determined that the quantity demanded of X of their tires per week is related to the unit price P by the equation X equals rad 144 minus P, where P is measured in dollars and X in units of 1,000. Compute the elasticity of demand when P equals 63, 96, and 108. So B is the demand elastic, unitary, or inelastic when P equals 63, 96, and 108. So those two questions go together. We have this, X equals F of P equals rad 144 minus P. So we need to get E of P. That's negative P F prime of P over F of P. You have negative P. Take the derivative of this. So you can rewrite it as 144 minus P to the 1/2. So that will give you a 1/2, 144 minus P to the negative 1/2. And then using the chain rule, we also have a negative 1. Divide by rad 144 minus P. Multiply it together. We'll have P divide by 2 on the bottom. We have a rad 144 minus P times 144 minus P to the 1/2. So that will give us P over 2 times 144 minus P. Now that we have this equation, we can figure out E of 63. So that is part of letter A. E of 63. 63 over 2 times 144 minus 63. We can also figure out E of 96. You can also figure out E of 108. So simplifying, 63 over 2 times 144 minus 63. Here we'll get 0.39 approximately. 96 divided by 2 times 144 minus 96. Get 1. 108 divided by 2 times 144 minus 108, 1.5. Then we can answer B. So is the demand elastic, unitary, or inelastic? So when P equals 63, the demand is inelastic. P equals 96, it's unitary. P equals 108, it's elastic. Now letter C. If the unit price is lowered slightly from 108, will the revenue increase or decrease? So here we also use the graph. On the left, E of P is less than 1, inelastic. On the right, E of P is greater than 1, elastic. So for 108, it's elastic, so it's on the right side. And if it's lowered slightly, then it's in this direction. The price is being lowered, so we move to the left. On the graph, it goes up. So the answer would be it would increase. The revenue will increase. D, at a unit price of $63, should the unit price be raised or lowered in order to increase the revenue? So 63, we're on the left side, inelastic. So if you want to increase the revenue, that's in this direction, then you need to increase the price. So you need to raise the price. E, at a unit price of $96, should the unit price be raised or lowered in order to increase the revenue? So actually this is a trick one, because at 96 it's already unitary, it's already at the top. So for this one, it's actually none. You can't really increase the revenue any further. So the revenue cannot be increased, since E of 96 equals 1 and it's unitary. So on the next page, here we have some derivatives of exponential functions, and here we have a product rule and also a quotient rule type question. First and second derivatives and also implicit differentiation. So for 3, find the derivative of e to the 3x. So you have f of x equals e to the 3x. F prime of x equals, we need to use the formula. So we need to get the derivative of the exponent. So that would be 3, and then we copy the original. So what is the formula? You have the derivative of e to the u equals u prime e to the u. Find the derivative of f of x equals e to the negative x. So f prime would be negative e to the negative x. We have f of x equals x cubed e to the x. So the derivative f prime of x is going to be, so you use the product rule. We got x cubed e to the x plus e to the x times 3x squared. So to simplify it, you can write x cubed e to the x plus 3x squared e to the x. 6, find the derivative of f of x equals e to the x over x. So you can use the quotient rule for this one. We got f prime equals x low d high, the derivative of e to the x is still e to the x minus high, which is e to the x, derivative of low, which is 1, over low squared. Find the first and second derivatives of f of x equals 2x cubed minus 3x squared plus 1. So first derivative would be 6x squared minus 6x. And then the second derivative, 12x minus 6. Find the first and second derivatives of the function f of x equals x squared plus 2 to the 5th. We got f prime of x equals, so you use the power rule, 5x squared plus 2 to the 4th, multiplied by the chain rule, 2x, to get 10x x squared plus 2 to the 4th. Then for the second derivative, f double prime of x, we use the power rule, 40x x squared plus 2 cubed, the chain rule, 2x, multiply to get 80x squared plus 2 cubed. Now, question 9 is to use implicit differentiation to find dy dx. X squared plus y squared equals 16. So differentiate both sides with respect to x. Derivative of x squared is 2x. Use the power rule to get 2y dy dx equals 0. Solve for dy dx. So that will give us 2y dy dx equals negative 2x. Dy dx equals negative 2x over 2y. So dy dx equals negative x over y. X squared minus 2xy equals 6. So take the derivative with respect to x on both sides. Derivative is 2x minus. So here you need to use the product rule. So you got a 2x derivative of y is dy dx plus y times the derivative of 2x, which is 2, equals 0. Distributing, got 2x minus 2x dy dx minus 2y equals 0. So solving, we have a 2x minus 2y equals 2x dy dx. Then we solve to get dy dx equals 2x minus 2y over 2x. Factor out the 2. And that will give us dy dx equals x minus y over x. So question 11. Find dy dx by implicit differentiation for the equation x squared y squared minus xy equals 8. So we need to get the derivative with respect to x, both sides. So here you got a product rule. X squared, derivative of y squared, which is 2y dy dx, plus y squared times derivative, which is 2x, minus, so we can put that here, and then in parentheses, here you got x derivative of y, plus y derivative of x, which is 1, equals 0. Simplifying, now we have 2x squared y dy dx plus 2xy squared minus x dy dx minus y equals 0. Now you need to solve for dy dx, so you need to group those terms together. Move the others to the other side. We have a y minus 2xy squared. Factor out the common factor of dy dx. Then we can divide that factor to the other side. We have dy dx equals. Now here we can factor out a y to get 1 minus 2xy. On the bottom, here we can factor out an x. So we got a 2xy minus 1. Now you can see there's going to be some cancellation. Here we have 1 minus 2xy and then a 2xy minus 1. So it is flipped. The subtraction is flipped. So we can factor out a negative 1 to get dy dx equals negative y over x. Thanks for watching, and don't forget to subscribe for more math videos.